Hello everyone. Welcome to the second section of Object-Oriented Programming with Python. In this section, we will learn two of the fundamental concepts in object-oriented programming, encapsulation and inheritance. This is the color coding we are using throughout this presentation to highlight important facts. As mentioned before, in this video, we will focus on the fundamental concepts of object-oriented programming. Hereafter, I will refer object-oriented programming as OOP. We have already discussed the concept of object and class. In this video, we will focus on encapsulation and inheritance. In the next video, we will learn about abstraction and polymorphism. At the end of this video, you should be able to apply the OOP principles, encapsulation and inheritance, in object-oriented programming development with Python. Before learning about the concept of encapsulation and inheritance, let's have a recap on the gaming scenario that we used last time. There is a mountain called Mount Doom in the center of the land of Mordor. The challenge is to climb to the top of this mountain. Whoever reaches there becomes the winner. A set of warriors go to climb this mountain. Each warrior has a walking stick which helps the warrior to walk. There are monsters in the land of Mordor. Some monsters are innocent. They will just steal the warrior's walking stick. But other monsters will kill the warrior and take the walking stick. If a warrior loses his stick, he is trapped. In the land of Mordor, there are magic trees. If warriors eat the fruit of these trees, they become immortal. The warriors are also two types, super warriors and normal warriors. Each super warrior has a pair of binoculars. They can look for any magic tree in the area. Normal warriors cannot see a tree unless they bump into one. We have marked the objects we can identify in this scenario. The land of Mordor, Mount Doom, warrior. There are two types of warriors, super warrior, normal warrior, walking stick, monster, magic tree, fruit, and binocular. Let's look at the encapsulation principle. Encapsulation means that the implementation details of a class are hidden from the rest of the code. In OOP languages such as Java, the attributes in a class must be defined as private. Python does not have the concept of private variables. However, by convention, we can use an underscore in front of an attribute if we do not expect it to be referenced from outside the class. In other words, an attribute with a leading underscore is treated as a private variable. Do not get confused here. Even the attributes with the leading underscore can be accessed anywhere in the code. It is just we decide that we will not do that. In other words, it's a good programming practice not to access attributes with the leading underscore from outside their class. In this code, the age attribute has a leading underscore. This means it should be treated as a private attribute. Since it should be considered a private attribute, we provide two methods known as getter and setter for other places in the code to get the value of the attribute and to set the value of attribute. Pythonic way to define getter and setter methods is using decorators. The method with property decorator, which is known as getter method, has the same name as the private attribute without the leading scope. It is used to access the value of the private attribute outside the class. To set the attribute's value, we define another method with the same name as the private attribute without the leading underscore and use the decorator private attribute name dot setter. In our example, age dot setter. We call this method the setter method. Using such getters and setters, we can add validation logic around getting and setting the value of the private attribute. For example, we can enforce a constraint that age should be greater than 0. If someone tries to set the age to a value less than 0, we throw an exception. Without the getter and setter methods, we cannot enforce such constraints. Refer to the code in the right side box to understand how getters and setters are used to access an instance attribute. In this case, the age attribute of the warrior class. Again, note that if we want, we can access _age attribute and set a value to it. But as a best practice, we do not access such private attribute. In addition to being a good programming practice, there is a benefit of accessing attributes via getters and setters. For example, look at the setter method of the age attribute. It has a logic that says that the value we use for age must be greater than 0. Otherwise, instead of changing the attribute value, we print out a message. So here, if you use the attribute directly, for example, _age from outside the code, we miss this validation step that has to be imposed on the age attribute. In other words, the age can be set to a value less than 0, and the warrior class has no way of checking this validation. On the other hand, other places in the code do not know about this validation logic. Due to encapsulation principle, the logic inside the age setter is not visible to the outside. In summary, the main benefit of using encapsulation is that it allows us to add constraints and logic when accessing and setting values of private attributes. Also, we can change the implementation of a method without changing the way this method is accessed from other places, as long as the method's signature does not change. This helps to keep our code simple, meaning that we can maintain the code easily. We can change one place of a code without having a significant impact on the rest of the code. Now let's discuss inheritance principle. First, why do we need inheritance? To understand the usefulness of inheritance, let's consider the warrior objects. Here we can see the classes of the normal warrior and super warrior. As you can see, most of the code is same in two classes. Thus, we say there is a code redundancy. This makes your code unnecessarily long and difficult to maintain, because every time you have to change a piece of code common to both classes, you have to make sure both places are equally updated. The solution is inheritance. We can use a superclass called warrior and move the code common to both normal and super warriors to this superclass. So now we need to update only one place whenever we have to make a change. This means less code redundancy and easy maintenance of the code. As you can see here, we have moved code common to super and normal warriors into the superclass warrior. Now our super warrior and normal warrior classes, which are called subclasses of warrior class, inherit the attributes and methods defined in the superclass warrior. This is achieved by passing the superclass name as a parameter to the subclass declaration. Such inheritance relationships are in abundance around us. For example, if we consider birds, we have ducks, cuckoos, etc. They are all birds, having some common properties such as 2 legs and a beak. However, different bird types may have attributes and methods specific to them on top of these common properties. For example, a duck's sound is different from that of a cuckoo. As another example, consider different person types. If we take an employee and a baseball player, they both have common properties, such as the name. However, they have attributes and methods specific to them as well. Baseball player is good at a sport while the employee is working in some office. Another example is the bicycle or the ship. In OOP, the inheritance principle explains the relationship between the superclass and subclass. A subclass can also be referred as a child class or derived class. Similarly, the superclass is also referred as a parent class or base class. As shown in the example of warriors, a superclass can hold the attributes and properties common to all subclasses. On top of these common properties, the subclass can have new attributes and methods or modify the methods defined by the superclass. This we refer to as the subclass extends the superclass. From inheritance, we establish a connection, a relationship between subclass and superclass. The relationship is called an is-a relationship. For example, we can say dog is an animal or super warrior is a warrior. Note that this is different from has a relationship, which usually exists between an object and its attributes. Note that has a relationship can exist between two objects as well. For example, if we take a walking stick as another object, we can say a warrior has a walking stick. Therefore, whenever you decide to make an inheritance relationship between two classes, see if an is-a relationship exists between these two classes. For example, it would not make sense to say a walking stick is a warrior. In Python, a subclass inherits all the class and instance members of the superclass. By members, we mean both attributes and methods. The inherited fields can be used directly, just like any other field in the subclass. If you want, you can declare an attribute in the subclass with the same name as the one in the superclass, thus hiding it. You can also declare new fields in the subclass that are not in the superclass. This is essentially what we mean by the subclass extending the superclass. The subclass will have all the superclass functionality and some more functionality. Like attributes, inherited methods can be used in the subclass directly as they are. If you want, you can have new method in the subclass with the same signature as the one in the superclass, thus overriding it. This is a perfectly valid implementation. You can, of course, declare new methods in the subclass that are not in the superclass. As for the constructor, the subclass can invoke superclass constructor by explicitly calling it using the keyword super. Even if you do not explicitly call it, the constructor will be implicitly called. Now we are going to use the inheritance principle in implementing the highlighted scenario of our game. This is the code we saw earlier. Now we have all the common warrior logic in the warrior superclass, and the super warrior and normal warrior extend this superclass warrior. But the problem is now both the normal and super warriors have the exact same attributes and methods. Now we go ahead and extend the common logic. In the super warrior, we have added a new method, fight, and binoculars as a new attribute. In the normal warrior class, we have defined a new rest method. Now, both subclasses have all the common functionality of the superclass and have additional functionality specific to them. Also note that the normal warrior accesses the default superclass constructor implicitly. In contrast, the super warrior class defines its own constructor because it needs to set its specific attribute binocular. In defining the constructor, the super warrior class explicitly calls superclass's constructor because otherwise superclass instance variables would not be available to it. Here we give an example of method overriding. In the Warrior superclass, we already have the method walk implemented. However, the walk method of the superclass has to be different from this default implementation, because a Super Warrior walks without resting. Thus, Super Warrior has a method with the same signature as the superclass method, but its internal implementation is different. If we call the walk method of a Super Warrior object, the method in the Super Warrior class will be called instead of the superclass method. Python does not support method overloading by default. This is because Python is an interpreted language. When we have multiple methods with the same name but different parameters, the method defined at the last is used. However, there are other ways to achieve method overloading. One approach is to use default values in the parameters. As you can see in the REST method, the rest time is set to a default value none. If you want, when we call the REST method, we can decide to pass a value to the rest time or not. Thus, the same method can be called in two different ways, with and without giving a value to the rest time parameter. I hope you noticed that method overloading and method overriding are different. In method overloading, the subclass has the same method signature as the superclass but has a different implementation. In method overloading, we consider a method inside the single class and change how it is called by the way we use parameters that have been given a default value. I hope you noticed that inheritance improves code usability and reduces code redundancy. With a superclass-subclass relationship, we also achieve code extensibility. To add a new subclass, all you have to do is to extend it from the superclass and add only the new functionality that the subclass will have. In addition, inheritance helps us to achieve abstraction. We will learn abstraction in the next lesson. In summary, in this video, we learned how encapsulation and inheritance properties are used in Python-based object-oriented programming. The next video will look at remaining principles, abstraction and polymorphism.